Okay, return of the original integrand. We have the integral of e to the negative x cosine of x dx. Looking at our islate, we have both a trigonometric function in the cosine of x, an exponential function in e to the negative x. So what we're going to do is we're going to let u be the trigonometric function cosine of x, and dv be the exponential function e to the negative x, and we always throw our dx in with the dv. du is going to be negative sine of x dx, and v is going to be negative e to the negative x. So our integration by parts formula, the integral of u dv is u times v minus the integral of v du. So the integral of e to the negative x cosine of x dx is u times v. We'll have negative e to the negative x cosine of x minus the integral of v du. Now the negative times the negative there is a positive, and so we'll end up with e to the negative x times the sine of x dx. Well, here I see another integration by parts. U is going to be the trigonometric formula sine of x, and dv is going to be the exponential formula e, if my pen will work, what on earth? There we go. All right, try that again. dv was my e to the negative x dx. So du is cosine of x, and v is negative e to the negative x. And so we're going to rewrite, and we have to rewrite everything. I know it's annoying, but you're going to see why in this example here. So we have the integral of e to the negative x cosine of x dx is negative e to the negative x times the cosine of x minus, and then we have u times v, so negative e to the negative x sine of x minus the integral of v du. Now it's going to be a negative here. Negative times a positive is a negative, so we'll switch the signs, and this becomes e to the negative x cosine x dx. And I forgot my dx right there. That's important to do. Now immediately red flag should be raised, because we're now ending exactly where we started. So we could do this process again of integration by parts, but in another 2 cycles we're just going to end up right back here. And so you might think this goes on forever, but it actually doesn't. And it works out really, really nice. What we're going to do is we'll go ahead and distribute our negatives here. E to the negative x cosine of x dx is negative e to the negative x cosine of x, negative negative positive e to the negative x sine of x, and then negative positive is a negative, the integral of e to the negative x cosine of x dx. Now take a second here and think about how can we figure out what this integral is if it's going to go on forever. And basically what we're going to do is we're going to kind of manipulate this equation in a way. Just as you can move this negative e to the negative x cosine x over to this side of the equation by adding, or move e to the negative x sine of x over to this side of the equation by subtracting, we're going to move this integral here. Okay, right now we're subtracting the integral of e to the negative x cosine x dx. We're going to add it over here, and we're going to have like terms. There's going to be 2 of those integrals. And so the way we're going to write that is twice the integral of e to the negative x cosine of x dx is negative e to the negative x cosine of x plus e to the negative x sine of x. And now we're going to divide each side by 2, just as you would solve a normal equation, gone, and then just put a plus c because we integrated, And there you have it. The integral of e to the negative x cosine x dx is negative e to the negative x cosine of x plus e to the negative x sine of x all over 2 plus c.